Good afternoon, everyone. Thank you for being here with us today. My name is Andy Bray from the Northeast Waste Management Officials Association, and we're here today for the webinar on RCRA compliance at cleanup sites, specifically waste treatment and land disposal restrictions. This webinar will cover what waste site cleanup staff and managers need to know about RCRA's requirements for waste treatment and land disposal restrictions. And it's the fourth in a four-part series that WMO has held. The prior webinars have included waste characterization and listed hazardous waste, area of contamination and contained in policies, and on-site management of remediation waste. And following the webinar today, you'll receive an email with how to access those past webinars as well as a recording of this webinar. Again, I want to thank you for being on today, and I especially want to thank our presenter, Mike Ellenbecker from the Wisconsin Department of Natural Resources, otherwise known as WDNR. In 1990, Mike began his career with DNR as a hazardous waste inspector. As an inspector, he visited over 1,600 facilities, which resulted in the discovery of over 2,400 violations. In 2010, Mike became the department's hazardous waste plan review specialist. As a plan review specialist, Mike was responsible for reviewing plan modifications and relicensing applications for Wisconsin's 12 treatment, storage, and disposal facilities. In 2013, Mike became the department's hazardous waste program coordinator. In this position, he provides technical expertise to the department's hazardous waste field staff, oversees the hazardous waste core team, and is responsible for developing guidance and policy on hazardous waste issues. Thanks again to Mike for being here today.
Thanks, Andy.
Before we get, my pleasure. Just a note or two on housekeeping for the webinar. Feel free to ask questions as Mike's presenting. We will field them as we're able. And for those that have not participated in a GoToWebinar session before, you can simply use the chat box to post your questions to Mike. Thanks for doing that. And without further ado, we will go ahead and get started.
This webinar is the fourth in a four-part series that covers the key RCRA compliance topics that can affect site cleanups. This presentation will cover what waste site cleanup staff and managers need to know about hazardous waste treatment and land disposal restrictions, or LDRs. Today's webinar, we will discuss the RCRA issues associated with the ex situ treatment of environmental media containing a hazardous waste and the land disposal restrictions that arise from this treatment. Part 1 is a discussion on determining if the environmental media contains a hazardous waste. This is the first step and needs to be done correctly. Otherwise, it could result in a hazardous waste being managed as a non-hazardous waste that could result in harm to human health and the environment, and or subject the facility to an enforcement action. Conversely, declaring a non-hazardous waste as a hazardous waste may result in additional costs for the cleanup. Part 2 is a discussion of how the hazardous waste treatment requirements apply to environmental media when managed ex situ. Part 3 is a discussion of how LDR requirements apply to environmental media when managed ex situ. And finally, Part 4 is putting it all together using examples. Part 1, determining if the environmental media contains a hazardous waste. Section 262.11 requires a person who generates a solid waste to determine if that solid waste at its point of generation is also a hazardous waste. Point of generation, or POG, is before any dilution, mixing, or other alteration of the waste. The solid waste determination includes identifying all applicable hazardous waste codes. It is at the point of generation the LDR treatment standards attached to the hazardous waste. In the preamble to the generator improvement rules, EPA made it clear that waste determinations must be accurate. Accurate hazardous waste determinations are necessary to ensure that the proper management of waste within the RCRA framework. In doing so, environmental protection will be enhanced and greater generator accountability fostered. Even if the waste may not be hazardous, overmanaging the waste is acceptable and meets the requirements in section 262.11 because the generator has made a determination intended to ensure, beyond a doubt, proper and protective management of the waste within the RCRA regulatory program. For contaminated environmental media, the point of generation is when the soil is excavated or the groundwater is pumped out of the ground. This table, still in draft, shows when a point of generation occurs when making a waste determination and when determining the LDR treatment standards. For remediation waste, the point of generation for the waste determination and for LDR purposes is when placement occurs. In other words, it is when the environmental media is actively managed or removed from the area of contamination. The concept of placement is important because placement of hazardous waste into a landfill or other land-based unit is considered land disposal, which triggers the land disposal restrictions and may trigger other RCRA requirements, including permitting, closure, and post-closure. Placement does not occur when waste is consolidated within an AOC, when it is treated in situ, or when it is left in place. Placement does occur, and additional RCRA requirements may be triggered when wastes are removed from one AOC to another, for example, for consolidation purposes, or when waste is actively managed, for example, treatment ex situ, within or outside the AOC and returned to the land. Contaminated environmental media are not considered solid waste in the sense of being recycled, abandoned, or inherently waste-like, as those terms are defined in RCRA. Therefore, contaminated environmental media cannot be considered a hazardous waste via the mixture rule or the derived from rule, since the contaminated environmental media is not a solid waste. The basis for stating that contaminated environmental media must be managed as hazardous waste is that they contain listed hazardous waste. This position is known as the contained in policy. EPA's application of the contained in policy to contaminated media was upheld in 1989 by the D.C. Circuit Court of Appeals in Chemical Waste Management versus U.S. EPA. These environmental media must be managed as hazardous waste until the media no longer contains the listed hazardous waste. There are 4 steps in the waste determination process. First, is it a solid waste? Second, is it excluded? Third, is it a listed hazardous waste? And finally, fourth, is it a characteristic hazardous waste? In the evaluation of the second step, some environmental media may be excluded from regulation under section 261.4. The 2 most likely situations where environmental media may not be regulated as a hazardous waste are petroleum contaminated media and manufactured gas plant waste, also known as MGP waste. When EPA published the Toxic Characteristic Rule in 1990, there was a provision that excluded petroleum contaminated media and debris from leaking underground storage tanks that failed TCLP for waste codes D018 to D043 from regulation as a hazardous waste. This is found in section 261.4B10. On March 13, 2002, EPA amended 261.24 to exclude MGP waste from TCLP testing. As a result of this action, the TCLP leaching test cannot be used to determine whether MGP wastes are hazardous under federal rules. Since MGP remediation waste is not a listed waste, it would only be classified as RCRA hazardous if it exhibits the characteristic of ignitability, reactivity, or corrosivity. MGP waste that is mixed with or contaminated by other non-MGP sources, for example, spent solvents, would not be covered by this exclusion. Determining if the environmental media contains a listed hazardous waste by the good faith effort. The hazardous waste listings apply retroactively to waste land disposed prior to the effective date of the listings. All waste meeting the listing descriptions are hazardous regardless of when they were disposed. The time at which a waste was disposed does not affect whether or not it meets the listing description. This does not mean that such waste must be exhumed for proper treatment. hazardous wastes are only subject to record requirements when placement occurs. When a facility owner or operator makes a good faith effort to determine if a material is a listed hazardous waste, but cannot make such a determination because documentation regarding a source of contamination, contaminated, or waste is unavailable or inconclusive, EPA has stated that one may assume the contaminated waste is not a listed hazardous waste and, therefore, provided the material in question does not exhibit a characteristic of a hazardous waste, the record requirements do not apply. It is encouraged that the lead agency use available site information such as manifests, storage records, and vouchers in an effort to ascertain the sources of waste or contaminants, but that when that documentation is not available or inconclusive, the lead agency may assume that the waste or its contaminants are not listed record hazardous waste. If, after a good faith effort to determine dates of disposal, a facility owner or operator is unable to make such a determination because documentation of dates of disposal is unavailable or inconclusive, one may assume disposal occurred prior to the effective date of applicable LDR restrictions. This is important because if hazardous waste was originally disposed of before the effective dates of applicable land disposal restrictions, and media contaminated by the waste are determined not to contain hazardous waste when it's first generated, the media is not subject to the LDR requirements. Wisconsin's hazardous waste program received a request for technical assistance from the Remediation and Redevelopment Program. In Wisconsin, all cleanup is done under the Remediation and Redevelopment Program, and not all of their staff are familiar with hazardous waste requirements. The Remediation and Redevelopment Program asks if the soils were a characteristic hazardous waste. The Hazardous Waste Program's review of the consultant's report showed that the soils were not a characteristic hazardous waste. However, the review did show that the consultant failed to do a good faith determination. The consultant's report lacked a discussion regarding any attempt to review or obtain records like safety data sheets, manifests, spill reports, or inspection reports, or an attempt to conduct interviews of former personnel who would have knowledge of the process and hazardous materials used, including waste handling of past spills. A quick review by the Hazardous Waste Program showed the following. Based on the above, it would be irresponsible to say, that is, not keeping with the good faith determination, that the information on the sources of the contamination is unavailable or inconclusive. The civil burden needed to show a release of a listed hazardous waste is a preponderance of evidence. This standard is met if the proposition is more likely to be true than not true. In other words, the standard is satisfied if there is a greater than 50% chance that the proposition is true. Determining if the environmental media contains a characteristic hazardous waste through representative sampling. Representative sampling is defined in section 260.10 and means a sample of the universe or whole which can be expected to exhibit the average properties of the universe or whole. In other words, every individual must have an equal chance of being sampled. Representative sampling is difficult. To do it correctly, it requires a plan to collect the samples. Imagine a consultant wants to determine if 1,200 cubic yards of soil contains a characteristic hazardous waste. The consultant collects 5 grab samples and places each grab sample into a quart glass jar. The consultant delivers the 5 grab samples to the lab. The lab then takes 100 grams from each sample jar for TCLP analysis. The consultant then uses the highest TCLP value to determine that the 1,200 cubic yards of soil contains a characteristic hazardous waste. Now imagine a bag that contains 1,000 marbles. 900 marbles are black and 100 marbles are white. If we want to characterize the bag, that is, we want to know the composition of the marbles in the bag, what is the absolute minimum number of marbles or samples that we would need to pull from the bag? The answer is 10, assuming that we're able to grab 9 black marbles and 1 white marble. However, what are the odds of grabbing 9 black marbles and 1 white marble with 10 grabs? Using these 2 examples, did the consultant collect a representative sample of the 1,200 cubic yards of soil? The answer is no. The consultant likely overmanage or overclassify the soil by using the highest T-cell p-value. This type of sampling and decision-making can result in the spending of tens of thousands to hundreds of thousands of dollars additional for remediation and disposal. Soils and wastes that are solids are highly heterogeneous. Therefore, determining the mean concentration of an analyte is highly susceptible to sampling errors from a variety of sources. There are two types of heterogeneity: compositional, which describes the variability of concentration between the particles that make up the population. Compositional heterogeneity drives how much sample to collect, the mass and volume. Distributional, which describes the non-random locations of the particles in the population. Distributional heterogeneity drives how the sample is collected, more random increments. Non-probabilistic sampling relies on the subjective professional judgment of the sampler to select appropriate sampling locations. The strategy is often chosen with the intent of collecting a minimal number of discrete samples to minimize costs. This approach can be effective depending on the sampling objective, accuracy of the available information, and the conceptual site model, and the abilities of the sampling design team. However, reproducibility of the individual discrete sample results is usually unknown and often likely to be poor because relatively few samples are collected and they are collected in an intentionally biased manner. The results do not support meaningful estimations of the mean concentration for a given area. Results from such sampling approaches are intended to be bias high. Any inferences drawn from the results about the overall population in unsampled locations are questionable. Probabilistic sampling designs are statistically based, i.e., they are unbiased to represent a specific population. Results can be used to make reliable inferences about the sampled population. They support statistical evaluations and can provide quantitative estimations of sampling area. Typical grid-based sampling is one example of probabilistic sampling. Incremental sampling methodology, or ISM, has been shown to be a valid and effective method for determining, with a higher degree of confidence, the concentrations of contaminants in heterogeneous soils, as long as the site-specific use of methodology is designed and implemented appropriately. ISM provides representative samples through collection of numerous increments of soils that are combined, processed, and subsampled according to specific procedures in order to reduce the deleterious effects that soil heterogeneity has on environmental data. To achieve the goal of reducing the potential effects of soil heterogeneity on sampling accuracy, the use of ISM at a site must be carefully planned. Specifically, decision units must be defined appropriately to ensure applicable cleanup levels are met. This is accomplished by taking into account the site history and characteristics in developing a conceptual site model that identifies the potential locations of the contaminations at the site by considering factors such as release and transport. Laboratory processing and subsampling must also be conducted appropriately to reduce heterogeneity within the collected samples. Verification procedures such as replicate sampling and subsampling may be required to confirm that the decision units have been defined appropriately. Field and within sampling heterogeneity have been sufficiently managed and data quality objectives are met. ISM provides representative samples of specific volumes of soil defined as decision units. An ISM replicate sample is established by collecting typically 30 to 100 increments of soil that are combined, processed, and subsampled according to specific protocols. 3 replicate samples from a decision unit are needed to assess variability and to calculate a 95% upper confidence level of the mean. ISM is increasingly being used for sampling soils at hazardous waste sites and on suspected contaminated lands. Proponents have found that the coverage afforded by collecting many increments together with disciplined processing and subsampling of the combined increments yields consistent and reproducible results. In most instances, these results have been preferred to results attained by more traditional discrete sampling procedures. ISM decision units are created based on site-specific conceptual models, project-specific needs, site history, and site-specific data quality objectives. Decision units represent the smallest volume of soil about which a decision is to be made. Decision units may be defined in regularly spaced and equal volumes in established exposure areas, or they may be based on irregular features of the site which define contaminant transport or receptor exposure. Decision units may take into account an understanding of contaminant distribution and geological consideration, for example, in and around source areas. Overall, decision units must be defined and appropriately to ensure that the concentration of the analyte in the soil is properly characterized and the data quality objectives are defined and met. Here is an example of an irregular shaped decision unit that is delineated by the tape. Decision units are not just limited to soil. Decision units can include building structures and record units like containers, tanks, and waste piles. The Dto process is a strategic planning approach based on a scientific method to prepare for data collection activities. The Dto process provides a systematic procedure for defining the criteria that a data collection design should satisfy. This includes 1, when to collect the samples, 2, where to collect the samples, 3, the tolerable level of decision error for the study, 4, how many samples to collect, and 5, balancing risk and cost in an acceptable manner. The Dto process will assure that the type, quantity, and quality of the environmental data used in decision-making will be appropriate for the intended application, resulting in environmental decisions that are technically and scientifically sound and legally defensible. The Dto process will also guard against committing resources for data collection efforts that do not support a defensible decision. Part 2, RCRA requirements applicable to treating environmental media. The definition of treatment is a two-part definition. The definition includes any method or process designed to change the physical, chemical, or biological character or composition of any hazardous waste so as to neutralize such waste, or so as to recover energy or material resources from the waste, or so as to render such waste non-hazardous, less hazardous, or safer to transport, store, or dispose of. The following are examples of hazardous waste treatment. A machine that compacts hazardous waste in a drum will meet the definition of treatment if the reduction in volume results in a change in the physical, chemical, or biological character or composition of the waste. Ex situ chemical oxidation of soils contaminated with chlorinated compounds using Fenton's reagent. Ex situ stabilization of soils contaminated with heavy metals using Portland cement and other reagents. Solidification of paint waste in a drum using an absorbent material. Precipitation of heavy metals from solutions. Neutralization of spent lead-acid batteries. And crushing lamps in a drum. Note that in situ treatment of soils and groundwater is not considered treatment under RCRA because the contaminated environmental media is not considered a hazardous waste. One of the difficulties of cleaning up a site in which the environmental media contains a hazardous waste is that a RCRA permit may be required when the cleanup involves on-site treatment, storage, or disposal. Obtaining a RCRA permit is a very lengthy and expensive process. Because of these difficulties in obtaining a RCRA permit and the desire to make cleanup easier from a regulatory perspective, EPA in 1998 published a rule titled Hazardous Waste Identification Rule for Contaminated Media. These new requirements made 5 major changes. First, they made permits for treating, storing, and disposing of remediation waste faster and easier to obtain. Second, they provided that obtaining these permits will not subject the owner and/or operator to facility-wide corrective action. Third, they create a new kind of unit called a staging pile that allows more flexibility in storing remediation waste during cleanup. Fourth, they excluded dredge material from RCRA Subtitle C if they are managed under the appropriate permit under the Marine Protection Research and Sanctuaries Act or the Clean Water Act. And fifth, they made it faster and easier for states to receive authorization when they update their RCRA programs to incorporate revisions for the federal RCRA regulations. The RAP rule is located in Subpart H of Chapter 270. The RAP rule was written in a question and answer format to make it easier for the regulated community to understand. The use of the plain language format in the RAP rule is still a legal requirement of the regulations. Treatment of hazardous waste normally requires a RCRA permit. However, this is not always the case. While Section 270.1c requires a RCRA permit for the treatment, storage, and disposal of hazardous waste, Section 270.1c2 provides exclusions from these requirements to obtain a RCRA permit. These exclusions include treatment in wastewater treatment units, treatment in 90, 180-day, and 270-day accumulation units, recycling, elementary neutralization units, totally enclosed treatment facilities, adding absorbents to waste, immediate responses, and burning small quantities of waste in on-site units. Today, we will discuss two of the RCRA treatment exemptions that you might encounter during remediation: wastewater treatment units and generator treatment in accumulation units. In May of 1980, EPA promulgated rules that required owners and operators of wastewater treatment units and elementary neutralization units to obtain a RCRA permit to treat hazardous waste in these units. This resulted in the regulated community questioning the necessity of regulating these wastewater treatment and neutralization facilities under RCRA. Shortly thereafter, in November of 1980, EPA proposed that wastewater treatment and neutralization facilities be effectively regulated under a permit-by-rule approach, which requires that these units comply with certain specific standards. Under the above-described approach, eligible wastewater treatment units would be deemed to have a RCRA permit if they comply with the special requirements established in the regulations. A generator treating hazardous waste in an on-site wastewater treatment unit or in an on-site elementary neutralization unit need not comply with 262.17, which is the conditional exemption from permitting requirements, because these units are already exempt from certain RCRA requirements. Specifically, wastewater treatment units and elementary neutralization units, as defined in 260.10, are exempt from RCRA treatment, storage, and disposal facility standards, as well as from the RCRA permitting standards. Note that a direct mechanical connection between the components of the treatment facility is not required for the tanks to be part of the wastewater treatment facility. Because there is no requirement that components of wastewater units to a facility be connected, there is no reason why wastewater could not be piped, trucked, or otherwise conveyed from one wastewater unit to another. This exemption from the RCRA requirements only covers a tank which treats or stores hazardous wastewaters or hazardous wastewater treatment sludges. In addition, the tank must be part of the wastewater treatment facility subject to regulations under Section 402 or Sections 307B of the Clean Water Act. Only the wastewater treatment unit, i.e. the tank, is exempt. The exemption does not follow or attach to the waste. For example, if such a waste is eventually destined for a wastewater treatment facility unit but is stored in a surface impoundment, the surface impoundment storage would not be exempt from RCRA requirements. Facilities generating, accumulating, and shipping the hazardous wastewaters would not be wastewater treatment sites. They do not treat before shipment and therefore are not part of the wastewater treatment system. They also are not subject to regulations under 307B or Section 402 of the Clean Water Act. Therefore, they could not be exempt under the wastewater treatment exemption. Moreover, the facilities shipping the waste off-site are subject to the requirements of 40 CFR Parts 262 and 263 relating to generators who offer waste for off-site transport, which includes the RCRA manifest requirements. It is important to note that it is not necessary that the Clean Water Act permit actually be issued for the units to be eligible for the RCRA exemption. It is sufficient that the facility be subject to the requirements of the Clean Water Act. A facility that discharges a pollutant covered under the Clean Water Act Sections 307B, 202W is considered to be subject to the Clean Water Act. The underlying assumption is that tanks discharging to the public sewer under local limits have sufficient EPA oversight under the Clean Water Act to prevent a decrease in environmental controls. If a facility is therefore operating tanks that discharge hazardous wastewaters to a PO2W, these tanks are exempt from RCRA permitting, as well as general facility standards and unit-specific standards under Parts 264 and 265. Wastewater treatment units might be used for soil washing. Soil washing is a technology that uses liquids, usually water, sometimes combined with chemical additives, and a mechanical process to scrub soils. This scrubbing removes hazardous contaminants and concentrates them into smaller volume. The wash water, which now also contains contaminants, is treated by an on-site wastewater treatment unit, which could result in the wash waters being reused in the soil washing process or discharged to a sanitary sewer or to the surface waters. The owner or operator of an eligible facility must ensure that the unit is constructed of sturdy, leak-proof materials and is designed and operated so as to contain a hazardous waste being treated or stored in the facility and to prevent spills or leaks of such hazardous waste into or on any land or water during the operating life of the facility. Releases from a wastewater treatment unit are not eligible for the wastewater treatment unit exemption. Additionally, releases from a wastewater treatment unit may subject the facility to corrective action, as wastewater treatment units are solid waste management units. Under Section 268.7A7, a one-time LDR notice must be placed in the facility file when hazardous wastewaters are treated in a wastewater treatment unit and become non-hazardous. This notice should include a statement that the hazardous waste was generated, a statement that it is excluded from definition of a solid waste under 40 CFR 261.4A1, and a statement providing the deposition of the waste, i.e., for example, discharge to the sewer. In order for a wastewater unit to qualify for this exemption, it must, 1, be part of a wastewater treatment facility that is subject to regulation under Section 402 of the Clean Water Act or Section 307B2 of the National Pollution Discharge Elimination System. 2, receive, treat, or store influent wastewater or generate it, accumulate, treat, or store a wastewater treatment sludge. And finally, 3, meet the definition of a tank or tank system in Section 260.10. The first criteria requires that the wastewater treatment unit be subject to regulations under either Section 402 or Sections 307B of the Clean Water Act. This means that the facility must have an NPDES permit under Section 402, be subject to an effluent guideline issued under Sections 301 and 402 of the Clean Water Act, or be subject to the pretreatment requirements of Section 307B of the Clean Water Act. You should be aware that state environmental regulations are also applicable and that the state may regulate such facilities different under the state program. Therefore, whether a RCRA or Part B permit is required for your state may be determined by the appropriate state agency. The second criteria requires that the wastewater treatment unit manage only hazardous wastewaters or hazardous wastewater treatment sludges. The term wastewater has not been codified in the context of the wastewater treatment unit exclusion. In a July 31st, 1981 letter, EPA described wastewaters as not concentrated chemicals or non-aqueous waste. Wastewaters are referred to waste which are substantially water with contaminants amount to a few percent at most. Sludge is defined in Section 260.10 as any solid, semi-solid, or liquid generated from municipal, commercial, or industrial wastewater treatment plant, water supply treatment plant, or air pollution control facility, exclusive of the treated effluent from the wastewater treatment plant. Thus, wastewater treatment sludges is any material that precipitates or otherwise is separated from the wastewater during treatment. The last criteria requires the wastewater treatment unit to be a tank or a tank system. Under Section 260.10, tank means a stationary device designed to contain an accumulation of hazardous waste which is constructed primarily of non-earthen materials, for example, wood, concrete, steel, or plastic, which provides structural support. And tank system means a hazardous waste storage or treatment tank and its associated ancillary equipment and containment system. Tanks are typically thought as cylindrical structures. However, for the purpose of the wastewater treatment unit, tanks can include, but are not limited to, air strippers, aeration tanks, blenders, clarifiers, dehydrators, dryers, evaporators, filters, grit chambers, presses, sludge digesters, sumps, and thickeners. In order for a tank to be exempt from the RCRA requirements, it must be dedicated for use to wastewater treatment unit. A tank that is used to store hazardous waste prior to off-site disposal and is also used to feed a wastewater treatment unit is subject to Subpart J of Chapters 264 or 265. Examples of ex situ soil remediation treatment includes chemical oxidation of soils contaminated with chlorinated compounds using Fenton's reagent, or stabilization of soils contaminated with heavy metals using Portland cement and other reagents. These types of treatments can be conducted in tanks and containers and can be done without a need for a RCRA permit. However, some forms of treatment by generators do require a permit. For example, incineration is regulated by the specific standards for incinerators under Subpart O of Parts 264 or 265. Note that burning hazardous waste is generally recognized as a method of disposal. Disposal does change a facility's regulatory status and is not allowed under Section 262.17. There is no regulatory language in Section 262.17 that prevents generators from treating their hazardous waste. Generators can treat hazardous waste that is generated on-site without a RCRA permit when the treatment occurs in containers, tanks, drip heads, and containment buildings. A RCRA permit would be required to store and/or treat hazardous waste that is received from off-site. Treatment often renders waste less hazardous or more amenable for further treatment, recycling, shipment off-site. A requirement for generators to obtain a permit for any on-site treatment would likely discourage such practices. Treatment must occur in the generator units specified in Section 262.17. These units are containers, tanks, drip heads, and containment buildings. Treatment must be done in compliance with the specific unit standards. For example, one provision of Subpart I requires that containers be kept closed during storage, except when adding or removing waste. Other sections in Subpart I provide that containers must be handled to prevent leaks or ruptures and address hazards posed by incompatibles, reactive, or ignitable waste. These requirements limit the extent that treatment could occur in containers. In addition, the hazardous waste that is being treated needs to be in compliance with all applicable parts of Section 262.17. For example, if the hazardous waste being treated is over the accumulation time period, then it is no longer eligible for treatment under the generator rules. If the waste is being treated on site and the treated waste or the treatment residue is destined to be land disposed, the generator has responsibilities under the LDR program. The generator must know the treatment standard applicable to their waste and either treat the waste on site to meet the treatment standard, send the waste off-site for treatment, or obtain a variance from the LDR treatment requirements. Generators who are managing and treating hazardous waste in tanks, containers, drip pads, or containment buildings to meet the applicable LDR standards found in Section 268.40 must develop and follow a written waste analysis plan, or WAP. Generator treating hazardous debris under the alternative treatment standards of Table 1 in Section 268.45 are not subject to the WAP requirements. Various aspects of soil mixing at remediation sites have been recognized by EPA as allowable under the federal program. For example, if the mixing occurs through the normal consolidation of contaminated soils from various portions of the site that typically occurs during the course of remedial activities or in the course of normal earth moving and grading activities, then EPA does not consider this to be intentional mixing of soil with non-hazardous soils for the purpose of evading the LDR treatment standards. Therefore, this is not viewed by EPA as a form of impermissible dilution. EPA recognizes that some situations may require soil mixing as part of the pre-treatment process to facilitate and ensure proper operation of the final treatment technology to meet the LDR treatment standard. For example, addition of less contaminated soil may be needed to adjust the contaminated soil BTU value, water content, or other properties to facilitate treatment. These adjustments would be for meeting the energy and or technical requirements of the treatment unit to ensure its proper operation. EPA views this type of pre-treatment step as allowable provided that the added reagents or other materials produced chemical or physical changes and do not merely dilute the hazardous constituents into a larger volume of waste so as to lower the constituent concentration or release excessive amount of hazardous constituents to the air. If the mixing or other pretreatment is necessary to facilitate proper treatment in meeting the LDR standards, then dilution is permissible. If you are a generator managing and treating hazardous waste in tanks, containers, drip pads, or containment buildings regulated under 262.17 to meet the applicable LDR treatment standards, you must prepare and follow a WAP. The WAP must describe all the procedures you will carry out to comply with the treatment standards. The plan must be kept on site in your records for review by inspectors, and the following requirements must be met. The WAP must be based on a detailed chemical and physical analysis of a representative sample of the hazardous waste being treated and contain all information necessary to treat the waste in accordance with the requirements of Part 268, including the minimum selected testing frequency. Waste shipped off-site must comply with the notification requirements of Section 268.7A3. Generator treatment greatly increases the importance of proper waste analysis in order to ensure that treatment is conducted in a safe manner and that standards are consistently met prior to disposal. A WAP is used to document the procedures used to obtain representative samples and ensure detailed chemical and physical analysis of the samples are conducted. It is also used to document any special handling procedures for the waste and must contain all information necessary for proper treatment of the waste. There is no required format for a WAP. Addressing these 10 elements will help ensure that the WAP meets the minimum requirements and address site-specific needs. 1. The purpose of the WAP should identify requirements and permit conditions for preparing and implementing a WAP at your facility and provide a brief outline or overview of the WAP. 2. The facility description should identify each hazardous waste type at your facility to include on-site managed waste, on-site generated waste, and acceptable waste, and restricted waste. Also, it should identify each process generating these wastes, provide the rationale for identifying each waste as hazardous, and provide appropriate waste classifications. Is it a wastewater or a non-wastewater? 3. The waste pre-acceptance and acceptance process needs to describe the rationale, information needs, and criteria for pre-acceptance for off-site waste streams, and describe the processes, policies, and procedures for evaluating incoming waste shipments for acceptance and appropriate on-site management. 4. The rejection policy should describe the policies and procedures that your facility will use for the rejection of waste received by your facility. 5. The discrepancy policy should describe the policies and procedures that your facility will use when there is a discrepancy between the waste designated on the manifest or profile and the waste received at your facility, including how the discrepancies will be resolved. 6. Sampling strategies and frequencies must describe how your facility selects the appropriate sampling procedures for effective waste characterization and describe the process for determining both initial sampling frequency and subsequent waste reevaluation. 7. Analytical parameters and test methods must describe how your facility selects the appropriate parameters and test methods. 8. Quality assurance, quality control, and data reports should describe your facility's quality assurance program and quality control procedures that ensure laboratory data are scientifically valid, defensible, and of known precision and accuracy. In addition, describe the data records your facility maintains and how long, where, and in what format each record type will be maintained. 9. Record keeping should describe your records your facility maintains and how long, where, and in what format each record type will be maintained. And finally, 10. Corrective and preventive actions should describe your facility's QA, QC, corrective, and preventative action programs for your waste analysis, including the process for identifying deficiencies early and procedures for rectifying any deficiencies. Waste determinations for characteristic hazardous waste are based on representative sampling. However, compliance with the LDR treatment standard for non-wastewaters is based on grab sampling. That is, one-time sample taken from any part of the treated waste rather than a composite sample That is, a combination of samples collected at various locations for a given waste or samples collected over time for that waste. EPA believes that grab samples generally reflect maximum process variability and thus would reasonably characterize the range of treatment system performance. The grab sample also meets the ultimate objective of the LDR program, that all the hazardous waste to be land disposed be treated in a way that minimizes threats to land disposal could pose, not just the average portion of the waste to be so treated, which is a possible result of using composite sampling. In addition, since grab sampling is based on an individual sampling event, it facilitates the collection of data to evaluate compliance. Part 3, applying the LDR requirements to environmental media. Small quantity generators and large quantity generators are subject to the LDR requirements. Very small quantity generators, formerly known as conditionally exempt generators, are not subject to the LDR requirements. When a small quantity generators or a large quantity generators waste will be land disposed, the LDR requirements must be met. In the November 7, 1986 Federal Register, EPA states, the agency is requiring that applicable parts of 268 Subpart D treatment standards for restricted waste be determined at the point of generation. To require otherwise would allow the generator to dilute waste in order to circumvent an effective date or otherwise alter the applicable treatment standards. EPA reaffirmed this position in the July 8, 1987 Federal Register and the May 23, 2006 Federal Register. For environmental media, the point of generation for making a solid waste determination for waste coding purposes is also the point of generation for the LDR requirements. LDR treatment standards apply to hazardous soils that are generated and managed in a manner that qualifies as placement on the land for the purpose of the land disposal restriction program. Soils to which the LDR standard apply are those soils that, 1, are removed from the area of contamination or are placed within the area of contamination. 2, are hazardous waste either because they contain a listed hazardous waste or because they exhibit a hazardous waste characteristic. 3, are prohibited from land disposal because they do not meet the applicable LDR treatment standards and they are not eligible for a variance, extension, or exemption. And 4, are destined for land disposal. Whether a soil is both generated and managed in a unit that qualifies as placement is dependent on a number of factors. For example, if hazardous soil is consolidated within an area of contamination, it would not be considered generated under the LDR program. If the soil is removed from the area, it is considered to be generated for the purposes of LDR, and it may not be managed in a manner that qualifies as placement without prior treatment to meet the LDR treatment standard. Section 268.2c defines land disposal as placement in or on the land, except in a corrective action management unit or staging pile, and includes, but is not limited to, placement in a landfill, surface impoundment, waste pile, injection well, salt dome formation, salt bed formation, underground mine or cave, or placement in a concrete vault or bunker intended for disposal purposes. The LDR requirements make no distinction in the duration of disposal. Temporary placement in a land disposal unit is land disposal just as much as is permanent disposal. As you can see, land disposal is just not limited to placement in a landfill. As discussed previously, hazardous waste that are discharged to a sanitary sewer or discharged under NPDES permit are also not subject to the LDR treatment requirements. EPA will consider allowing land disposal of restricted waste if the petitioner can demonstrate to a reasonable degree of certainty that such disposal will not allow migration of hazardous constituents from the disposal unit for as long as the waste remains hazardous. This demonstration must include the components outlined in Section 268.6a and meet the sampling, testing, and analytical criteria outlined in 268.6b. Each petition must include a monitoring plan, as outlined in Section 268.6c1 through 5, that describes the monitoring program installed at or around the unit to verify continued compliance with the conditions of the variance. A successful no migration petition will allow land disposal of a specific waste at a specific site. If the excavated media is a characteristic hazardous waste, the generator shall comply with Section 268.9A, which requires a generator to determine the underlying hazardous constituents, or UHCs, of their characteristic hazardous waste. Underlying hazardous constituent means any constituent listed in Section 268.48, the table UTS, Universal Treatment Standards, which can reasonably be expected to be present at the point of generation of the hazardous waste at a concentration above the constituent-specific UTS treatment standards. Soils that are listed hazardous waste and are being treated under the alternative treatment standards must be treated for all constituents that are reasonably expected to be present. Does the characteristic code also need to be identified as an underlying hazardous constituent? The regulatory language at Section 268.48A would state yes. However, EPA has explained in two documents that the characteristic code does not need to be identified as an underlying hazardous constituent. If the contaminated environmental media is both a listed hazardous waste and a characteristic hazardous waste, then what characteristic codes apply to the contaminated environmental media? First, all applicable listed hazardous waste codes would apply. If the treatment standard for the listed hazardous waste addresses the constituent causing the waste to exhibit the characteristic, only the listed waste and the treatment standard applies. If the treatment standard for the listed waste does not address the constituents causing the waste to exhibit the characteristic, both the listed waste and the characteristic waste code and the treatment standards applies. A large part of the LDR program is paperwork. Under Section 268.7A2, a one-time notification is required for contaminated soil that has not met the LDR treatment standard and is being shipped off-site for further management. If the contaminated soil meets the LDR treatment standard, then the LDR notification shall also include a certification statement. Section 268.7B3, 26, and Section 268.9D requires that treatment facilities send a one-time notice and certification form with the initial shipment of waste or contaminated soil to the treatment or land disposal facility. EPA explains in 2 RO documents and 3 federal registries that the one-time notice and certification form is not applicable when the waste is treated and disposed at a Subtitle D landfill. EPA's position on this issue is not reflected in any regulatory language in 40 CFR 268, as the code does not state that the land disposal facility must be a Subtitle C facility. This LDR form is applicable when a hazardous waste has dropped out of RCRA. This may be due to the hazardous waste being excluded from the definition of a hazardous waste or solid waste, or the hazardous waste being exempt under Section 261.2 to 261.6. As we discussed earlier, the contained-in policy for contaminated environmental media is not codified, so you would not find it between Section 261.2 to 261.6. However, the code states, excluded from the definition of a hazardous waste or solid waste. I believe that since the contained-in policy can exclude environmental media contaminated with illicit waste from the RCRA, that the LDR form is applicable. The one-time on-site LDR notification form should include the generator information, how the waste was generated, the applicable waste codes, the exclusion or exemption that caused the waste to fall out of RCRA, and how the waste will be disposed of. In 1998, EPA promulgated alternative treatment standards for hazardous soils subject to land disposal restriction and designated soil as a new treatability group. Under the new soil standards, a facility must treat all constituents subject to treatment to a 90% reduction of the constituent level in the soil, capped at 10 times the non-wastewater universal treatment standard. Additionally, facilities must decharacterize any soil that exhibits the characteristic of ignitability, corrosivity, or reactivity. Section 268.49D defines constituents subject to treatment as any constituent listed in Section 268.48, i.e. the UTS table, that are reasonably expected to be present in any given volume of contaminated soil, except for fluoride, selenium, sulfides, vanadium, and zinc, and that are present at concentrations greater than 10 times the universal treatment standard. Generators of contaminated soil are not required to monitor soil for the entire list of underlying hazardous constituents to determine the constituents subject to treatment. Instead, EPA allows generators of contaminated soils to reasonably apply knowledge of the contaminants that are likely to be present in the soil and use that knowledge to select appropriate UHCs or classes of constituents for monitoring. For soils containing illicit waste, using the alternative soil treatment standards may encompass constituents subject to treatment that do not require treatment under Section 268.40, which are the Waste Code specific standards. The treatment standards for illicit waste in Section 268.40 do not require identification or treatment of UHCs. However, under the alternative soil treatment standards, facilities must identify and treat all UHCs reasonably expected to be present in both characteristic and listed soil. Facilities operating in states that have adopted the alternative soil treatment standards have the option of treating hazardous soils in accordance with the original Waste Code specified standards in Section 268.40 or the alternative section in 268.49 soil standards. The regulations at Section 268.44H4 allow EPA and authorized states to grant site-specific LDR treatment variances for contaminated soils if the level or the method specified in the soil treatment standards would result in concentrations of hazardous constituents that are below natural background concentrations at the site where the contaminated soil will land disposed. The alternative soil treatment standard should not be used to establish site-specific soil cleanup standards. The purpose of the land disposal restriction treatment standards is to ensure that prohibited hazardous wastes are properly treated before disposal, i.e., treated so that short and long-term threats to human health and the environment are posed by the land disposal are minimized. The soil treatment standards, like other land disposal restriction treatment standards, are based on the performance of specific treatment technologies. In contrast, most soil cleanup levels are based not on performance of specific treatment technologies, but on analysis of risk. Technology-based treatment standards are not necessarily appropriate surrogates for site-specific risk-based cleanup levels. Like soils, hazardous waste debris also has an alternative treatment standard that can be used to meet the LDR treatment requirements. Debris means solid material exceeding 60 millimeters, about 2.4 inches, in particle size that is intended for disposal and that is a manufactured object, or plant or animal matter, or natural geological material. Debris can be a hazardous waste if it exhibits a characteristic of a hazardous waste or contains a listed hazardous waste. In 1992, EPA established land disposal restriction treatment standards specific to hazardous contaminated debris. The debris-specific treatment standards established by these regulations are based on application of common extraction, destruction, and contaminated debris treatment technologies and are expressed as specified technologies rather than numeric criteria. As with the contaminated soil treatment standards discussed earlier, generators of hazardous contaminated debris may choose between meeting either the debris treatment standards or the numerical treatment standards promulgated for the contaminating hazardous waste. EPA determined that hazardous debris treated to comply with the debris treatment standards using one of the identified extraction or destruction technologies would be considered no longer to contain hazardous waste and would therefore no longer be subject to regulation under RCRA, provided the debris does not exhibit any of the hazardous waste characteristics. This contained-in determination is automatic. No agency action is needed. Note that this automatic contained-in determination does not apply to debris treated to the debris treatment standards using one of the identified immobilization technologies. EPA considers contaminated environmental media to no longer contain hazardous waste when they no longer exhibit a characteristic of a hazardous waste and when concentrations of hazardous constituents from listed hazardous waste are below health-based levels. Generally, contaminated environmental media that do not or no longer contain hazardous waste are not subject to any RCRA requirements. However, as discussed below, in some circumstances, contaminated environmental media that contained hazardous waste when first generated remain subject to the LDR treatment requirements even after they no longer contain hazardous waste. The determination that any given volume of contaminated media does not contain hazardous waste is called a contained-in determination. In the case of media that exhibits a characteristic of a hazardous waste, the media are considered to contain hazardous waste for as long as they exhibit a characteristic. Once the characteristic is eliminated, the media are no longer considered to contain hazardous waste. Since a determination can be made through relatively straightforward analytical testing, no formal contained in determination by EPA or the authorized state is required. Just like determinations about whether waste has been adequately decharacterized, generators of contaminated media may make independent determinations as to whether the media exhibits a characteristic of hazardous waste. In the case of media that are contaminated by listed hazardous waste, current EPA guidance recommends that contained in determinations be made based on direct exposure using a reasonable maximum exposure scenario, and that conservative health-based standards be used to develop the site-specific health-based levels of hazardous constituents below which contaminated environmental media would be considered to no longer contain hazardous waste. Since this determination involves development of site-specific health-based levels, the approval of EPA or the authorized state is required. The contained in policy for environmental media has not been codified. Part 4, putting it all together. Excavated soils from historic surface spills of gasoline at an airport are placed into several roll-off boxes. The soils exhibit the D008 and the D018 characteristics. Excavating the soil is a point of generation and now subjects the soil to RCRA. A review of the safety data sheet for the gasoline helps us to identify which ingredients in the gasoline are also listed in the UTS table located in section 268.48. This was accomplished by using the CAS numbers in the safety data sheets and comparing these CAS numbers to the CAS numbers listed in the UTS table. To understand what RCRA requirements would apply, let us review the following. 1. Is contaminated environmental being generated under RCRA? As we discussed in slide 6, placement occurs when the soil is excavated from the AOC and placed into a separate unit. 2. When did the spill occur? As we discussed in slides 4, 5, and 46, soils that exhibit a characteristic of a hazardous waste at the point of generation are subject to RCRA. When a spill occurs, does not affect if the soils are not a hazardous waste. 3. Is the spill a listed or characteristic hazardous waste? D008 and D018 are characteristic codes. 4. Was representative sampling done for the characteristic waste determination? As we discussed in slide 15, a representative sample is required for making a characteristic waste determination. 5. Do any exclusions apply, like the petroleum exclusion? As we discussed in slide 8, the petroleum exclusion only applies to petroleum contaminant media and debris from leaking underground storage tanks that fail TCLP for waste codes D018 and D043. The soils were impacted from surface spills. In addition, review of subpart C of chapter 268 and footnote 8 of the UTS table showed that there are no waste-specific prohibitions. 6. How is the soil to be disposed of after treatment? As we discussed in slide 47, constructing a screening berm is a form of land disposal. 7. Can we get a variance from the LDR treatment standards? As we discussed in slide 54, a treatability variance is an option that can be used to meet the LDR requirements. However, since this site does not meet the conditions for the variance, a variance would not be granted by EPA. 8. Do the LDR treatment standards apply since land disposal is occurring? As we discussed in slide 46, soils exhibiting a characteristic of a hazardous waste at the point of generation must meet the LDR treatment standards prior to land disposal. 9. Do the UHCs need to be determined? As we discussed in slide 49, soils that are characteristic hazardous waste will require that the generator determine if there are underlying hazardous constituents or UHCs. 10. Is treatment occurring on site to meet the LDR requirements? Yes, as we discussed in slides 40 to 43, when treating to meet the LDR standards, a waste analysis plan is required. Under section 268.49, we need to determine what type of treatment we are using, solidification versus metal removals, and what type of analytes we'll be treating for, organic versus inorganic, as this dictates whether we conduct total testing or TCLP testing. 11. Is a RCRA permit needed? As we discussed in slides 37 to 39, a RCRA permit is not required provided that the treatment is done in compliance with the generator standards of Part 262. Note that the roll-off box is subject to the container standards of subpart I of part 264. Since the site is treating the soils to meet the LDR treatment standard, a WAP is required. 12. What LDR treatment standard is being selected? As we discussed in slide 54, it would be advantageous to use the alternative LDR standards for soils because these standards are easier to meet than the Table 1 treatment standards in section 268.40. 13. Is an LDR notification and/or certification form needed? As we discussed in slides 52 and 53, hazardous waste soils are subject to the LDR paperwork requirements. The table below shows what is the minimum LDR treatment standards that each analyte needs to meet. Using TCLP's 20 times rule, we can see that there is a potential for benzene to fail TCLP. Additionally, lead's minimum treatment standard fails TCLP. If a hazardous contaminated soil exhibits a toxic characteristic when it's generated, then once the soil meets the LDR treatment standards and is decharacterized, the soil may be disposed in a subtitle D landfill or placed back on the land. If, however, a hazardous contaminated soil exhibits a toxic characteristic when it is generated, and this soil meets the LDR treatment standards, but is not decharacterized, i.e., it is still above the TCLP level, then the soil must be disposed in a subtitle C landfill or a hazardous waste landfill. Since the goal is to use the soils to build a screening berm, the minimum LDR treatment standard for lead cannot be used as it would still cause the soils to be a D008 hazardous waste. Additionally, TCLP testing needs to be conducted for benzene in order to determine if 200 milligrams per kilogram would fail TCLP. The site's goal is to bring the excavated soils and concrete debris to a subtitle D landfill for disposal. 1. Site used to be a dry cleaner and stopped operations over 25 years ago. Soils and the concrete floor are impacted with tetrachloroethylene, trichloroethylene, and vinyl chloride. The constituents are often associated with the cleanup of dry cleaner sites. The soil and the concrete will be a listed hazardous waste if disposed of. Intact standing buildings are not considered discarded until destroyed. As discussed in slide 55, the alternative LDR treatment standard for debris could be used on the concrete floor. 3. The site acknowledges that soils are impacted with a listed hazardous waste. As discussed in slides 9 to 13, a good faith determination is needed to determine if the environmental media has been impacted with a listed hazardous waste. 4. Site also acknowledges that impacts to the soil occur mercifully before and some likely after the effective LDR dates. As discussed in slides 11 and 46, the impact dates are important as they determine if the LDRs apply to the soils when actively managed. Soils contaminated with a listed hazardous waste must meet the LDR treatment standards when land disposed, unless the soil was contaminated before the LDR standards apply to the listed waste and a no longer contains determination has been issued by the regulating authority at the point of generation. 5. 139 soil samples were collected and analyzed. As we discussed in slide 25, the DTO process can be used to reduce the number of samples analyzed. 6. Site used Fenton's reagent to treat the soils in situ and ex situ. As we discussed in slides 4 to 6, in situ treatment of soils that contain hazardous waste are not subject to RCRA. Ex situ treatment of soils becomes subject to RCRA when placement occurs. 7. Site used roll-off boxes to contain and treat the soils that are excavated. As we discussed in slides 37 to 39, a RCRA permit is not required, provided that the treatment is done in compliance with the generator standards of Part 262. Note that the roll-off box is subject to the container standards of Subpart I of Part 264. Since the site is treating the soils to meet the LDR standards, a WAP is required. 8. Treatment occurred during the winter months, resulting in one of the roll-off boxes being on site for 110 days before treatment could begin. Since the roll-off box has been on site for more than 90 days, the generator treatment exemption under Section 267.7A5 cannot be used to treat the hazardous waste in this roll-off box. The only realistic option is for the generator to ship this roll-off box off-site to a TSD facility for treatment and disposal. Note that the generator could have requested and likely been granted from the regulating authority a 30-day extension under 262.17B. Can we issue a no longer contains determination for roll-off box 1? Yes, since the site-specific cleanup values have been met. In addition, the alternative LDR treatment standards have also been met. This soil may now be land disposed. Can we issue a no longer contains determination for roll-off box 2? No. While it appears that the site-specific cleanup level values have been met, there is a question if the 140 milligrams a kilogram of tetrachloroethylene sample would fail TCLP. In addition, the alternative LDR treatment standards for the tetrachloroethylene sample in question has not been met. It is over twice the LDR treatment limit. As we discussed in slide 44, the LDR treatment standards are based on a single grab sample. Samples cannot be averaged to meet the LDR treatment standard. Roll-off box 1 could be retreated on site. Understanding the LDR requirements is complicated at best. Perhaps the best resource in knowing how to apply the LDR requirements to environmental media is EPA's guidance on demonstrating compliance with the land disposal restrictions alternative soil treatment standards. In addition to the resources listed here, this presentation also contains resources either in the slide itself or in the notes. This concludes today's presentation. I sincerely appreciate your attention today. So to sum up the important takeaways, 1, understand when environmental media becomes subject to RCRA. If treatment can be done in situ and a no longer contains determination can be issued prior to excavation, then RCRA does not become an issue. 2, avoid overclassifying environmental media as a hazardous waste, as this can increase costs and hinder cleanup from a regulatory perspective. Use the Dto process and incremental sampling methodology to help characterize the site, not only for making a hazardous waste characterization, but also for determining what the decision units will be. 3, know that representative sampling is needed for making a characteristic waste determination, and that grab sampling is almost always needed to determine if the LDR treatment standards are met. 4, most ex situ treatment can be done without a need for a RCRA permit. However, this requires planning and understanding of the RCRA requirements. Make sure that the treatment to be conducted is appropriate to the season. For example, do not operate a wastewater treatment unit in the outdoors in the middle of winter. 5, understand that issuing a no longer contains determination for environmental media contaminated with a listed hazardous waste does not automatically mean that the environmental media can be land disposed. A review is still needed to determine if the LDR treatment standards still apply to the environmental media. And finally, 6, use the alternative treatment standards for soil and debris, as it lowers costs and can increase the willingness of the RPs to conduct site cleanups. This is the first time I am giving this presentation, so if I had missed anything or you think that there is a better way to present or explain a slide, please let me know. Before we go on to the Q&As, I would like to share a short joke with you. According to a radio report, a middle school in Oregon was faced with a unique problem. A number of girls were beginning to use lipstick and would put it in on the bathroom. This was fine, but after they put on their lipstick, they would press their lips on the mirror, leaving dozens of little lip prints. Finally, the principal decided that something had to be done. She called all the girls to the bathroom and met them there with the maintenance man. She explained that all those lip prints were causing a major problem for the custodian, who had to clean up the mirrors every night. To demonstrate how difficult it was to clean the mirrors, she asked the maintenance guy to clean one of the mirrors. He took out a long-handled squeegee, dipped it in the toilet, and then cleaned the mirror. Since then, there has been no lip prints on the mirrors.
Mike, thanks so much. Great note to end on with the joke. It's a funny one.
Enjoyed it.
Yeah, very much so. For all of the attendees, Mike's been fielding some questions as we go, but if you have any unanswered questions or anything you'd like clarification on or any comments you'd like to make, please use the chat feature at this time through the GoToWebinar panel. Did have one request for clarifying point from Ross Bonnell in Connecticut, so I'm going to go ahead and unmute Ross. Hopefully technology is our friend today, and this will work okay. Ross, you should be unmuted now.
Yeah, hi,
Hey,
Andy.
Ross.
Can you hear me okay?
Yes, coming through loud and clear.
Great. I just wanted to, for those of you who may be on this webinar that were not on the prior webinars, Mike spoke quite a bit about what we referred to in those webinars as the contained in policy, by which a particular remediation waste can be determined not to contain a listed hazardous waste provided it meets certain criteria. And I just wanted to point out that, or remind folks that may not have been around for the session where we talked in greater detail about that particular concept, that EPA basically allows states to develop policies akin to their own contained-in policy. Most states have one. Most authorized states have one. And those policies do differ from state to state and have different criteria associated with them. So people need to be aware of the contained-in policy in their particular state and make sure that they're applying the criteria of that policy for contained-in determinations that they're performing in that state. Also, I'll just point out that for wastes that are generated in one state and are moved to another state, some states require a review of any contained-in determinations for remediation waste being disposed of in their state that was generated out of state. So in other words, they're going to want to review the receiving state may want to review the contained-in determination of a waste that was determined not to contain a listed hazardous waste under another state's contained-in policy. That's all I have.
Thank you, Ross.
Thanks, Ross.
Just one thing to add. This is Mike here. I believe the PowerPoint presentation will go up on the website. This was a kind of a scripted presentation. So if you actually download the PowerPoint presentation, the narrative I use is in the notes, and it's also in the notes you'll find the resources or the source of where that information came from.
Thanks so much, Mike. And we will have an email out to folks in the next day or two where you can access that. I believe that with the invitation, you probably already had a link to our overall series, but we'll also follow up with links to the previously recorded sessions. And I just wanted to thank Mike again for taking time to do this. And, you know, on a personal note, it was fun to try something new from a technology perspective with the pre-recording, and I think everything seemed to go well, Mike.
It did, I think.
So thanks for taking the extra time to put that together.
Yeah, if you guys got any more follow-up questions that you can't think of right now but want to send me, by all means, I think you have my email address. Send me an email. I'll see if I can answer it.
Thanks, Mike. Appreciate it. And thanks to all for taking time out for this. And with that, we'll end the webinar and have a great day, everyone.
Bye, everyone.